Moving on to example 3, again we're going to want to factor. The top has a greatest common factor of x, which leaves x squared minus x minus 6. The bottom has a greatest common factor of negative 3, which leaves x squared plus x minus 6. Alright, so keep on factoring. I get x times x minus 3, x plus 2. And then on bottom I get negative 3 times x plus 3, x minus 2. Okay, so now with all that information I can find any holes. There are no factors, even though there's a whole lot of stuff that looks similar. There are no factors that are in both top and bottom, so there are no holes. X-intercepts would be at 3, at negative 2, and then a common one that is missed is 0. This factor gives me a 3, this factor gives me a negative 2, and that factor of x I can make 0 by plugging in a 0. In vertical asymptotes, I'm going to end up with x equals negative 3 and x equals positive 2. And then finally, horizontal asymptotes, because a cubic divided by a squared, the top is larger. There is no horizontal asymptote, there's a slant asymptote, which you could find by doing long division, but we're not necessarily caring about that at this point, so we're going to just continue on. Alright, so let's plug in our things that we have. We have vertical asymptotes at negative 3 and at negative 2, at positive 2. We have x-intercepts at negative 2, at 3, and at 0. And I'm not going to go ahead and spend any time plugging in points. I'm just going to go ahead and graph this because I've graphed it previous. The graph itself looks like this. Graph there. Slant asymptote there. And then there's the slant asymptote. So you can see where the slant asymptote would have gone. And then again, that's enough information for us to decide limits at the vertical asymptotes or the limits as x approaches positive or negative infinity. All right, finally, one more example done together. If I factor the top, I get x plus 3, x minus 2, and on the bottom I factor out a negative 4, which leaves me with x squared plus 4x plus 3. And I'm going to go ahead and factor that again. Top is already factored. Bottom would be x plus 3, x plus 1. So as you can see, I have factor of x plus 3 on top and bottom, which means that negative 3 is a factor. Once I do that, I'm going to remove that point. X equals 2 will be an x-intercept. X equals negative 1 will be a vertical asymptote. And because they are the same, y equals negative 1/4 is going to be the horizontal asymptote. Let's go ahead and put that information on our graph. Vertical asymptote at negative 1. Horizontal asymptote at negative 1/4. X-intercept at 2. And then I'm not going to plug in the hole yet because I don't know where the graph is, but once I figure out where the graph is, then I'll be able to add that spot of discontinuity in. Alright, so the the x-intercept at 2 tells me that my graph has to be above the vertical asymptote on this side. And then if I need to test a point like negative 2, that will tell me if it's going to be above or below the x-axis. In this case, it's going to be below the x-axis. And so when I draw this, I need to remember that I have a hole at negative 3. So as I'm drawing this graph, I need to remember that I have a hole at negative 3, and then I can finish plugging that in. And I can tell where that hole is going to be at. In fact, I probably should have done that to begin with by just plugging in a -3 into what's remaining. So if I plug in a -3 into what's left over, I end up with -5 divided by -4 times -2, which is -5/8. So you can kind of see I'm not too far off. I was about -1, but it should be a little bit above that. So let's redraw that with that in the right spot. So the hole should be about right there. And there is the rest of the graph. So you can see, again, enough information to tell limits at the asymptotes, either vertical or horizontal. Go ahead and pause your video at this point and work on the examples below. Once you finish those 4 examples, unpause the video, and then you can see your work and see how your work compares to the notes. All right, I'm assuming that you've finished examples 5, 6, 7, and 8. So I will leave these here for you to go through, and then these are also posted on the website on Schoology. So if you have any questions on these, again, go ahead and pause the video here to work through your examples. If you have any questions, either shoot me a message through Schoology or email, or jump in on one of those class meetings that we have on Wednesdays or Thursdays and ask your questions there. There's another homework assignment posted. So looking ahead, next week we're going to start working through limits algebraically, and being able to work with these rational functions is going to come in pretty handy.